Alright guys, my name is Mr. Malope. Uh, I want us to look into this nice mathematical problem here. We want to integrate this function here, which is your 1 over 1 minus sine x with respect to x, right? So we have different techniques of how to handle integration problems, right? So in this scenario here, we noticed that if we were to look into some of these techniques, they're not going to be applicable here, like your u substitution. If we let this guy to be u, we are hoping to see something which is already within the integrand there. So if we differentiate this numerator, we are hoping that the derivative becomes something which is already there. But in this case, we don't have uh, anything that will support us to use the u substitution, all right? Then when we look into integration by parts, we are interested into a product of two functions, all right? A product of two functions of which those two functions are from two different classes, right? Two different classes on which we can try to maneuver within the by parts technique. But in this case, the by parts will be useless, right? So we then move to integration by partial fractions, all right? Okay, integration by partial fractions will only work if and only if we have a quotient of two polynomials, all right? So if we look into this is not a polynomial, all right? This is not a polynomial, but is in the form of a rational function, all right? Is in the form of a over b, but at the end of the day, this numerator, find it's a polynomial of order 0, but this denominator is not a polynomial, all right? So how are we going to handle this guy? So the idea is to just play around and try to manipulate this given integrand, all right? So I'm just going to extract the integrand there. So I'm going to have my 1 over sine of x, right? So I want to manipulate this in such a way that I don't tamper with the originality of this function, all right? So what I'm going to do is I'm going to multiply this by 1 plus your sine x over 1 plus your sine x, all right? Okay, sorry about that. I hope you guys can see what I have there. Let me just verify if that is clear. Okay, so that is clear. So I'm just going to try and multiply it out. So if I do that, this will imply that we have 1 multiplied by that, which is 1 plus your sine x over, and this becomes a difference of 2 squares, so I can write this as 1 minus your sine squared of x. Then at the end of the day, this will imply that I'll have something like 1 plus your sine x all over. This is from the identity rule of trigonometry, right? So I know that a cosine squared plus a sine squared is equals to 1. So I can just say this guy, if I look into the identity property, right? So let's have the identity property. If I take this guy to the other side, it means that I will have 1 minus this square of the sine function of x, right? And that will be nothing but equivalent to that. So this will just be the cos squared of x equals to 1 minus sine squared of x. So I can see that this guy, I can replace that guy by this particular gentleman here, right? So this guy will be nothing but the cosine squared of x. All right, I hope we are still together. I hope we are still together, right? So I just need space, so I'm going to erase that guy because I've used that guy and it benefited me, right? So now let's try to then move on. Let me just put my duster there. Right, so we are just going to play around there. So I will continue and say that this guy implies that I can split that because I have a plus b over c. So we know that a plus b over c is actually the same as 1 over c plus b over c. So we're just going to apply that knowledge from our our early grades, right? Our early grades. Okay, so that's what we have there. So I'm just going to apply this. So this will be my A, right? So this A, this guy will act like my A, this will be my B, this will be my C. It will act like that. So I'm just going to then say 1 divided by this. So this guy, I'll just have 1 divided by the cosine squared of x. Then if I look into this guy here, if I look into this guy, I can just write this as plus sine x over the cos square of x. So that's what we have there, right? Remember, our idea is to integrate this guy. So we're just trying to express this in a different form. All right. So we know that 1 over cos of x is actually, right, is actually your secant, right, is actually your secant squared of x, right, is actually your secant squared of x. So this one will just be your sec of x. That guy will just be a sec of x, but we are interested into 1 over cos squared of x, which is actually 1 over cos x squared, and this will just imply that we have the secant squared of x there, right? So that's what we have. So we have this gentleman here. Don't worry about that, don't worry about that. So it means that I can replace that by, I can just say this is the same as, this guy is the same as the secant squared of x, and by the sine over the cosine squared of x, right? So that's what we have there, right? So I'm just going to try and make space here. So now I'm going back to the problem that I'm supposed to integrate. So I'm just going to say the integral of 1 over 1 minus sine of x dx is actually integrating the secant squared of x, then plus the sine of x over the cosine squared with respect to x. So this is what I have, right? So we have properties of integration, of which states that if we have the sum of two functions and we want to integrate this, so we are allowed to then integrate the first function with respect to x, then integrate the second function with respect to x. At the end of the day, if we were to factor out the integrals, our common factor and the integrating agent as our common factor, will go back to this original guy here, right? So I'm going to apply that here. I'm going to apply that, and then I'm going to say this is equals to the integral of the secant squared of x dx, then add by the integral of the sine x over cosine squared of x dx. So this is what I have, right? This is what I have. So allow me, guys, to just erase this side, okay? So let me just erase this side so that we can have space to work out everything there. All right, so allow me to use my finger there, right? So we're going to have two problems. So I'm going to label this guy here, I'm going to label it star, right? I'll come back to it. So I want to integrate the secant squared of x dx. All right, now if we go back to our derivatives, all right, we know that if y is equals to the tangent of x, then what is the derivative? The derivative is actually your dy over dx, meaning that you are differentiating y with respect to x. This is actually your secant squared of x. So it means that since this is integration, right? Since this is integration, meaning that we are reversing, we are just going back, all right? We are anti-differentiating, right? We normally call it the antiderivative, right? So if I want to integrate this guy will actually go back to the original, right? So it means that I can come here and say that this guy is actually the tangent of x add by add by c. Right, so this is what we have here, right? So I've sorted this guy. That guy is well solved because it's well known to be the tangent of x. It's antiderivative. The antiderivative of this guy is actually the tangent of x added by a constant of integration, since we are looking into indefinite integrals. Right, so we're left with the second part. We are left with the second part, so I'm just going to highlight that. And we then try to work out the second part. Right. So if we look into the second part, we have the integral. We have the integral of sine x divided by cos squared of x, and our integrating agent is the dx there, right? So our variable of integration is x, right? So how are we going to handle that guy, right? So to handle this guy is very simple, right? Because we know that if we let u to be one of the cosines here, right? One of the cosines, because if we were to look into the numerator, we know the derivative of the numerator is actually going to be cos, right? But it's going to cancel one of these, and we want something which will cancel the entire part of this or the entire part of that. Then we are left with one function. So that is u substitution, right? U substitution, it states that the integral of a composition with respect to x is actually letting the inner function to be u, and then integrate the function of u. And this, at the end of the day, is just going to be an antiderivative function. It's going to be an antiderivative function. I think I left something here, right? So we have something like this, right? This is our u substitution. So this is how it looks like. So at the end of the day, if you let u to be this, right? If you let u to be your gx, let's put that. If we let u to be our gx, right? Differentiating this u with respect to x will actually be something like this, right? So we can see that at the end of the day, what we have here, if we apply the u substitution, will end up with something of this type. So we're going to replace this. So we'll be left with a function of a single variable. So the composition will be normal, right? So that is u substitution in a nutshell. All right, but we are into applying that u substitution in our guide there. All right, so which one seems to be a composition? Right, we can see that this guy here seems to be a composition, plus we can express this as a cosine, right? A cosine of x to the power of 2. So you can see that we have a function inside and a function outside, which is raised to the power of 2. All right, so let's just try then to work it out. So I'm going to say, let u be the cosine function. All right, so this will imply what? This will imply that if we differentiate u with respect to x, if we differentiate a cosine, the derivative will just be negative sine of x with respect to x. All right, then now let's go back to our guy there. So this guy will actually be, right? So if we apply our u substitution, this guy is going to be subjected to a parameter u now. So this will actually be the integral of sine x all over u. Remember, u is cosine, right? But here we have cosine squared. So what will be this guy? This guy will actually be our u squared, all right? Now, since we have introduced a parameter u, it means that we need to get rid of all the variable x, right? Plus we want to work out the antiderivative with respect to u, right? So I'm going to say multiply by. Now I go back to this guy here. I want to make this the subject of the formula. So we all know we just need to divide both sides by negative sign. So this will actually be, this guy will actually be your negative du over sine of x. And this is what we have. Right. Then from there, we notice that this guy and that guy are going to undo each other, and we'll be left with what? We'll be left with the negative 1 over u squared du. All right, so things seems to be interesting now. Things seems to be interesting. Then let's double check. We can then try to express this guy as u negative du. Then we can apply the n plus 1 rule, right? I normally call it the n plus 1 rule to say we want to reverse the function of which is a power function. So for us to reverse it, in most cases when we differentiate a power function, we normally take the power, multiply the coefficient of the variable, and then subtract 1. So we'll just do the reverse here, because we have a property which states that the integral of this function, of all power functions of this form, is actually you reversing the power rule. So instead of subtracting 1, you add 1. All right, so this is what we will end up with. All right, so I've run out of space. I'll just try and come back here because I know what is it that I want to solve for, right? So let's have this. Just want to keep this guy safe there because we'll come back on this star here. All right, so I will then say that this guy, which is the integral of sine of x all over cos squared of x dx, is actually the reverse of the power rule here. So you need to be very careful here. So what is my n? My n is negative 2. So this I'm going to have minus into your u to the power of minus 1. Because if I substitute my n here, right, this is the n. So if I take the n and substitute it here, don't mind the variable there, right? For as long as we have a variable to the power of n with respect to its integrating agent, we can then just apply the normal power, right? The inverse power rule of integration, right? So if we then have our n is negative 1, add by negative 2, add by 1, it becomes negative 1, right? So this is what I have here, all over. Remember your n, we said that it's negative 2. So it's going to be what? Negative 1. Then we can add our constant of what? Of integration. Right, so we are almost there. We are almost there. So let me just write what is going to happen. Right, so if we simplify further, this negative 1 and negative 1 are going to undo each other. So I'll be left with the u minus 1 by c. But I know exactly what is u. U is actually this guy here. All right, so allow me then, guys, to erase this side. Right, allow me to erase this side so that I can take this guy to the other side. So this is actually 1 over u add by c, right? But I know what I chose to be u, right? We chose u to be the cosine function. So this guy is actually 1 over the cosine function add by what? Add by c, right? So I have this guy now. I have this guy and I have this guy. So now let's go back to our problem. So it means that this guy, which is 1 over 1 minus sine of x dx, is actually what? Is actually the antiderivative of this guy, which we obtained here to be the tangent of x add by c, then plus the antiderivative of this guy, which you obtained to be what? To be 1 over the cosine x, all right, the cosine at an angle of x add by c, right? So I can erase this now. I can erase this and be able now to write down the solution of my answer there. Right, so my antiderivative for this guy, which is 1 over 1 minus sine of x dx, is actually what? It's just the tangent function of x, then add by 1 over cosine of x, Then I have this constant plus a constant. So if I take a constant and add a constant to it, we all know the answer is going to be a constant, right? So if I have 1 add by 3, the answer will be 4, and 4 is a constant. So I can just come here and say that the answer here will just be a constant. So this becomes the antiderivative. This becomes the antiderivative of our integral. All right, so this is what we have. Thank you so much, guys. I hope you guys enjoyed what we have solved there. Thank you so much.